Welcome to this live broadcast. We're going to discuss physics paper 2. Remember to subscribe. Remember to share with friends. Okay, so we're going to go through a certain paper here, and I hope you people shall benefit. I'm checking a few settings here. Remember to invite someone. Yeah, we can get started now. I think I'm done with my settings. So we are told that in number 1, that Sophie cleaned a zinc plate and fixed it on the cap of a overcharged gold leaf electroscope. When she shone ultraviolet light on the zinc plate, she noticed that the leaf divergence slowly decreased. The leaf divergence slowly decreased. Before you respond to this question, something you're supposed to know is that the gold leaf is already charged, so it's having a specific charge. Then, when UV light is brought near the cap being metallic, then the UV light will cause what we call photoemission, and electrons will get produced at the cap. Then we are told that the leaf divergence slowly decreased. Part 1. What is the initial charge of the electroscope? We are saying it is negatively charged, because for divergence to decrease, there must be repulsion. And when UV radiation is brought near or is shown on the plate, electrons are produced, which means for them to cause a decrease in divergence, then they must be repelled. They must be repelled away. Then we have to explain now. So photoelectrons emitted from the negatively charged zinc plate are repelled. They are repelled. As a result, Now, this repelled is a very key word. As a result, the leaf divergence has to decrease now. A setup transformer, a step-up transformer, is designed to operate from 20-volt supply and deliver electrical energy at 240 volts. If the transformer is 90% efficient, determine the current in the primary coil when the output terminals are connected to 240 volts 100-watt light bulb. What you're supposed to understand about efficiency of a transformer is that efficiency as a formula now, efficiency is usually given as power output out of power input. These ones are multiplied by 100, expressed as a percentage. So when we work out that now, we should get 90. We should get 90. So that's why we are saying the power input is going to be in the primary. You know, power generally, electrical power is given by VI. Electrical power is given by VI. So we are talking of the primary to operate from 20 volts, then to deliver an electrical power at 240. Determine the current in the primary. So we have 20 by unknown V. Yeah, 20 by unknown current. So power input is going to be, or power in the primary. Power input is the power in the primary. It's going to be 20, which is the voltage there, multiplied by a known current. But for the output, power output is already known, 100 watts. Power output is already known as 100 watts. So according to the formula, when we take 100 watts, we multiply by, that is the power output now over power input, which is 20 by unknown current. That's why we are calling it I at P, IP. When we express it as a percentage now times 100, we're supposed to get 90%. So mathematically, when you simplify that, you're supposed to get a current of 5.556 amperes. 5.5. Yeah. I think tonight the network is very stable. Very stable, actually. Very stable. Let us follow up with physics. Somebody is requesting for agriculture paper. That will not be practical tonight. Let's just work with what I operate with. I deal with physics. Okay, state two conditions for total internal reflection to occur. Actually, the examiner would have just gone to directly state the two. We can even say the two, because there are only two conditions that must align for total internal reflection to occur. One, light must be traveling from optically denser medium to a less optically dense medium. That is the first condition. I will show you how that one works. Number two, the angle of incidence must exceed the critical angle. The angle of incidence, this is how you should be reading actually. The angle of incidence in the angle of incidence in the denser medium, must be or must exceed the critical angle. Must exceed the critical angle. Now, this is what we mean. This is what we mean. When light is traveling, let's say this is a two media. Let me illustrate that. Let's say we got two media here, media 1 and media 2. This is a media 1, media 2, and another case we have media 1, media 2. So in the first case, if we got light moving such that it is incident like that, then we can now draw what we call normal at that point. We will have refraction behaving this way, away from the normal. So refraction would be away from the normal. Refraction would be away from the normal if this one is the denser. M1 is denser. M1 is denser. But in this case, if M1 is less dense, if it is less dense, then we will have a very different scenario. Very different scenario. Let me do a normal there. Then I talk about a ray of light incident at the interface like that. Now the refraction will occur this way, such that it is towards the normal. Towards the normal. Not like the first case whereby it is happening away from the normal. Now in this case whereby light is traveling in case B, light is traveling from less dense to denser medium, we are saying that refraction is happening towards the normal. Towards the normal. Now, in the first case, whereby it is from denser to less dense, refraction is away from the normal. Away from the normal. This is to mean that with the time, in the first case here, part A, with the time, very soon the angle of refraction, this one, will be equal to 90. Then beyond that, total internal reflection is going to occur. Total internal reflection is going to occur. But in the second case here, as long as the ray is being refracted away from the normal, there is no way the ray will be internally reflected in the first medium. There is no possibility. Part 4. Explain why an alpha particle, this one is an alpha particle, the symbol for alpha, we write it this way, but the symbol is, so we are saying that explain why an alpha particle produces a straight line track in a cloud chamber, whereas a beta particle produces a strangely, which is called irregular track. Irregular track. We are being told that an alpha particle or alpha particles are massive. They are heavier, but beta particles are lighter. Relative mass of an alpha particle is 4 units, while that of a beta particle is 1,840 of a unit, a very small mass. Now, this is almost an electron, which is almost having a negligible mass. Let me explain this. Actually, the answer that could have come in a better way, it could have been, the reason why, I must make learners aware that the reason why we are talking of a straight line track, it's because, the tracks show that they show the ionized particles, the ions formed. They are the ones which form the tracks. So the straight line tracks are symbols of a heavy ionization. So in simpler terms, we would have said alpha particles cause heavy ionization. They cause a heavy ionization. They cause a heavy ionization. Heavy ionization. Or more, they cause ionization. The ionization effect is greater than beta particles, which are lighter, moving very fast, and not having time. These ones cause lead to ionization. So the ions now are the ones to form the tracks. They are the ones to form the tracks. That is why the tracks by beta particles are heavy. Number 5. Thank you guys for following. Remember to subscribe. Remember to share with friends. Remember just to invite your friends. Just remember to invite your friends to this powerful live broadcast. Remember to invite your friends to the powerful live broadcast. Otherwise, thank you so much and all the best as you continue learning with us. Yeah, Shifting Grades Online School is here for you and wishing you success. All right, let's look at this question. We're being told that the figure below shows a faulty domestic wiring system. Identify the fault and hence sketch the correct setup. You see where the switch has been fixed? That is wrong. So the switch is supposed to be on the live wire this way. So it has been corrected in the second setup. The switch is connected in the neutral instead of the live. So the correction is shown there. Arrange the following in order of increasing energy. Another way, this is just a trick for boys because they have never seen the electromagnetic waves or the electromagnetic spectrum arranged in order of energy. They have never seen that, but it's a trick whereby you should know that energy equals to Planck's constant times the frequency. So in other words, the greater the frequency, the greater the energy possessed by the electromagnetic radiation. And this is to mean that now increasing energy is another name of increasing frequency. Increasing frequency. Increasing frequency. That is simply what it means. So a student must be very sharp when unfamiliar language has been applied. You must be able to grasp. You must be able to grasp what the examiner is trying to mean. So that is what it means. In other words, that is what it means. Arrange the following in order of increasing energy. So we have visible light, infrared radiation, X-rays, UV radiation, radio waves. So when you begin arranging them, you'll begin with radio waves, infrared, visible light, UV radiation, then X-rays, according to what is available here. The spectrum contains 7 of them. You should know the order so that no matter the ones they bring, then you can arrange the available ones. State one detector of infrared radiation. State one detector of infrared radiation. We have a thermopile, bolometer, blackened bulb thermometer. Yeah, the heater effect on the skin, the heating effect on the skin is one of the detectors of infrared. The figure below represents an object O placed 10 centimeters. 10 centimeters in front of a diverging lens. F is the focal point of the lens. The focal point means principal focus. Principal focus. Yeah, the principal focus. Draw rays to locate the position of the image. Draw rays to locate the position of the image. I hope the diagram is clear. Yeah, thank you for following. Thank you for following. Draw rays. We know that there are three important rays. Only three important rays in the drawing of ray diagrams. And one of them is a ray which is close and parallel to the principal axis, this one. This ray is diverged according to the nature of the lens provided in this particular question. The ray is supposed to diverge, but in a way that it is originating from F. So it diverges as though it's coming from F. So it's going to be reflected away as though it is coming from F, as you can see. The other ray, which goes through the optical center, the optical center is this, the mid of the lens. So a ray that goes through the optical center passes undeviated. Now, as it passes undeviated, it's going to intersect the virtual ray, which is originating from F. Yeah, they're going to intersect, and an upright image which has been diminished is going to be formed. So it's virtual because there is a virtual ray. It's also diminished because it is smaller than object. So that's where we get the image now. That's where we get the image. Let's look at number 8. Just a good question here. Just a good question. Study the circuit diagram below and answer the questions that follow. We have a resistor there, 12 ohms, 8 ohms, then a cell there. We have a battery here made of several cells. Let's look at the question now. If the power in the 12 ohm resistor is 6, the power in the 12 ohm resistor is 6 watts. Determine part 1, the current in the 8. Something that we're supposed to know is that according to the arrangement of these resistors, which is a parallel arrangement, voltage is the same, because in a parallel arrangement of components, in a parallel setup of components, we usually say that voltage is usually the same, or two components parallel to one another are operating at the same potential. So how do we get power? Power is given by VI. Again, power equals to V squared over R. V squared over R. There are several formulas for power, which means V squared equals to power times R. And with this, we can also say that V equals to the square root of PR. So what is the voltage in the 12 ohm resistor? Is going to be the square root of the power there, which is 6, multiplied by the resistance there, which is 12. Yeah, the square root of 6 by 12. If that is the voltage, it is also going to be the voltage in the second one. So voltage in the 8 ohm resistor, now that they are in parallel, shall also be the same value. So we talk of 12 by 6. That will be the same. Now that in the 8 ohm resistor, we also have the voltage. Remember, we are determining current there. And according to the first formula here, how do we get current? Sorry. From not even that formula, but from the Ohm's law, IR. So how do we get current? V over R, which means current in the 8. Current in the 8. In the 8, current in the 8 ohm resistor is going to be voltage there, the square root of 12 by 6, divided by the resistance there, which is 8. And this is going to give us a value equivalent to 1.061. 1.061 amperes. 1.061 amperes. 061 amperes. Yeah, that is it. Then we are also talking about the total voltage. The total voltage is uniformly moving through. The voltage from the setup here is also the voltage in the respective resistors. So the voltage is going to be the square root of 12 by 6. So the square root of 72, which is 8.485 volts. 8 point. Yeah. So that's how we work it out. Work it out. We go to the next. Wow, number 9, a very interesting question. Explain how lighting a matchbox near the cap of a charged electroscope would cause the electroscope to discharge. Remember that when the matchbox is going to light up, the air around it will get ionized with all types of ions. And now the electroscope is charged, whether positive or negative. Let's say it's negative, for example. So if it's negative, it shall attract the positives from the air. And once it attracts the positives from the air, now they will neutralize the negatives and the electroscope will remain discharged. If it was positively charged, now it attracts the negative charges from the air and it becomes neutralized. It becomes neutralized and remains in a discharged condition. Number 10, sketch the electric field pattern for a negative point charge placed near a positively charged plate. Sketch the electric field pattern for a negative point charge placed near a positively charged plate. So this is a negative point charge. Then we are placing it near a positive plate. This is the positive plate. Now we should know that electric field patterns move from positive to negative. They move from positive to negative. From positive to negative, they never cross one another. They never cross one another. They are close to one another where the field is very strong. Therefore, the field lines will just move as indicated. That's a basic concept. Please refer to electrostatics 2. We got a number 11 here. We got a number 11. Define work function. Define work function of a metal. Define work function of a metal. This is the minimum work, or rather, the minimum energy required to dislodge an electron from a metal surface. This is the minimum work, or rather, the minimum energy required to dislodge an electron from a metal surface. Okay, I might give it a different definition. Allow me differ with the, not differ, let me give a more precise definition. Work function is the minimum energy. The minimum energy required by a specific metal for photo emission to take place. For photo emission to occur, or for photo emission to take place. Remember, when we say that for electrons to be dislodged, for an electron to be dislodged from the metal surface, do you know that we can also talk of dislodged an electron? To dislodge an electron, okay, to dislodge an electron. But basically, we can make it a term used on photoemission, whereby for an electron to be dislodged by a certain radiation, which is being shown on a metal surface, then that minimum energy required, we call it photoemission, or the minimum energy required below which photoemission does not occur. The minimum energy for a metal below which photoemission does not occur. Below which photoemission does not occur. Below which photoemission does not occur. Yeah. Let's look at section 2. I want to remind the followers to kindly subscribe to this platform. Remember to even share so that you may invite a friend. Please remember to invite friends for us. I'm also inviting friends. Okay. Please ensure to be sharing. Ensure to be sharing. Ensure to be sharing. 12. Part A. A magnet compass. A magnet compass needle is placed below a current carrying conductor, is shown below a current carrying conductor. So this one is below a current carrying conductor. Then we are told to draw to show direction. So this is the direction it will be moving to. You can use the Ampere's swimming rule. The Ampere's swimming rule. The Ampere's swimming rule. Part B. State Fleming's left-hand rule. It's also called the motor rule. So it states that if the left hand is held with the thumb, the first finger, and the second fingers mutually at right angles, so that the first finger points in the direction of magnetic field, the second finger points in the direction of current, then the thumb will point in the direction of motion. We know that when magnetism, which leads to a certain force, therefore, if we got the first finger pointing in the direction of the magnetic field, then the second one in the direction of the current, which is flowing in the given conductor, then we say that the thumb will point in the direction of motion. The thumb is going to point in the direction of motion. State two physical modifications that can be made on the coil of an electromagnet to increase its magnetic strength. So for you to produce a stronger magnet, an electromagnet, that one is studied in Form 2 actually, whereby we talk of an electromagnet. We say that when an electric passes through a conductor, a magnet is created. Even in Form 2 Topic 1, whereby we talk of magnetism, one of the ways of magnetizing a material is through electricity, the electric method, because hmm, allowing current to pass through a conductor causes magnetism. Then what factors might increase the strength of the electromagnet that is produced? One is increasing the number of turns per unit length, and the other one increasing the length of the solenoid. Also, the amount of current itself, which is passing, the amount of current passing through the solenoid will also increase the strength of the electromagnet which is produced. Mhm. Explain the working of the telephone receiver. Telephone receiver, that one is directly from book 2 physics. Please ensure that you review your notes, and that will really help you as a student. So we are saying that when varying electric current passes through the solenoid, the strength of the magnetic field in the diagram changes correspondingly. Then the diaphragm vibrates and produces the sound made by the person through the microphone. We can look at a question here from the cathode rays and the cathode ray tube. What is it saying? The question says, state the function of the following parts of the CRO, cathode ray oscilloscope. The grid is to control the intensity of the beam or the spot. In simpler terms, to be more precise, I think about the function of the grid. It also controls the brightness. It controls the brightness of the spot at the screen. Now there is a screen where the beam is directed to. So it controls the brightness. And in other exams or in a different context, somebody might even be told to explain how the grid ensures that it has controlled the brightness of a spot. How does the grid ensure that the intensity of the brightness at the screen is controlled? And we usually say that when the grid is made more negative, that's less positive. More negative, then we say fewer electrons are attracted, and hence, as less brightness is seen at the screen. When the grid is made more positive, it means because it has become more of the negatives, more of opposite charges to the negative electrons now. So when made more positive, more electrons will be attracted. Being of opposite charge, they get attracted, and hence a brighter spot is going to be seen. A brighter spot shall be seen. Then we go to the X plates. The X plates. These ones are also called the horizontal plates. The horizontal plates. And with the horizontal plates, we say that their work is to deflect the beam of electrons horizontally. Hope you are following and doing so carefully. I hope you're following and doing so carefully. I'm careful to see whether the network. Mhm. Let's see, the network is a bit it's also wanting to become shaky.